Hello, everyone. This is my project, Coastal Connections. This does not follow the exact same format as traditional science, but it's similar. I started out with some observations along Rhode Island's coast, and I had a hypothesis of everything being connected through ecology. I did a literature review primarily in the Pell Marine Science Library, but as well with online sources and papers. For my fieldwork, I shadowed local scientists and I asked them about their research, and they told me a lot about the local area. And to process everything that I was learning, I created a series of paintings. These paintings are intended to display the concept of ecology by visually connecting parts of coastal science. Science communication studies have shown that narratives are an exceedingly effective ways of conveying knowledge. And I have a question for my audience to think about during this presentation, and it's, what is ecology to you? This project focuses on Rhode Island coasts, especially the Narragansett Bay. I visited mainly the southern coast, but I looked at literature and talked to scientists about all the coasts there that you see. The Narragansett, Wampanoag, Niantic, and Pequot tribes have lived in these lands since the glaciers receded 14,000 years ago. They carefully managed the area and had a stable ecosystem for a long time. I walked along the coast at Black Point Trailhead. I looked out towards the sky and it was a bright blue against the dark blue of the ocean coming towards me. The sand in front of me was a wide berm down to the waves as they carried the grains up and down the coast. There are changes along the coast in each wave between the crest and the low, in each tide in the day, between the high and the low, and each season with winter storms and with summer calm. Since the creation of the bay, which it was originally a lake, sea rise has come in all around and connected it to the ocean. This will continue into the future as the coast fluctuates through time. The waves slowly carry sand along the shore in what is known as longshore transport. They pick up a bit of sand at an angle and they go straight back down. So over time, the sand flows in one direction or another along the beach. As I walked further down the beach, I came to a big mat of seaweed. It was very smelly in the sun, brown and decomposing. I went back with some books, identification books, and I picked through the mats. Although there were many different from what I saw in the books, they all had a similar branching pattern of one going into two, going into two, going into two, like a fractal. The waves would pick up this algae and toss it over, and I could see them turn red-brown as the sun shone through them. Nearby, there is a drainage pipe carrying runoff from nearby houses straight down. It was right next to the algae, which made me wonder about the history of pollution in this land. When the colonizers arrived, there were thousands upon thousands of beavers upon the land. Thousands upon thousands of beavers were killed for their pelts. This caused the rivers, which flowed very slowly in ponds and held a lot of water, to rush forth into the bay carrying a lot of sediment. The salt marshes, acres upon acres, were drained for livestock to graze. In more developed areas, seawalls were built to separate the water from the land. This creates a big buildup of energy as the waves splash against them and are reflected back, as opposed to the smooth gradient that it was before. Roads are built to fragment the ecosystems between town and marsh and city and country. Overall, there is a great hardening of the gradient as humanity tries to put the ocean in one place and the land in another. Prior to 1973, 65 million gallons per day of sewage flowed into the bay through the rivers and from the drains. After that, the EPA set a Clean Water Act, which has greatly improved the pollution, but there is still a legacy of contaminants in the river, and further work needs to be done to clean up the bay. The gray lines in this painting show a potential future of division, but it is not set in stone. This all was a lot, but as I continued my walk down the coast, I came to a very beautiful sight. I came to the rocks. I walked down into a shallow pool at low tide, and there was a carpet of soft seaweed that met me. There were light and dark green, pink and red, and all different textures, from hairy to pointy to roughly, but they were all smooth underneath my hands. The wind was blowing strong and the waves crashed against me. There was salt on my lips, and it was a very peaceful day. This brought me to thinking about the algae that was even smaller than what my eye could see. Diatoms are photosynthetic. They're microscopic algae that are green when they're alive, green to brown, and when they die, you can clean them and they become prisms that the light can shine through. Their cell wall is made of glass, which is the same thing as silica, and unlike other algae, they require silica in order to reproduce and proliferate. They are very common in the Narragansett Bay, as well as most water sources along the coast. Unlike most organisms, they respond positively to ocean acidification, and they do not require a lot of calcium carbonate to reproduce. All of these diatoms are drawn from a book in a library, so they accurately represent what you could see in a microscope. I continued down the coast and I came to a salt marsh. Salt marshes lie in mixed fresh and saltwater areas. They have several feet thick of peat, and some places I saw up to a meter. And this bed is like a sponge for wave energy that calms it down and for toxins. We took some soil cores down to the glacial sediment. I held glacial till in my hands and I could see intact roots from thousands and thousands of years ago. Layers upon layers of toxins that the salt marsh has held. First, when the livestock came in, that was a lot of waste that changed their development. Afterwards, with nuclear testing, they absorbed lead from the air that was coming in from the islands. In these pictures, you can see a fiddler crab and a periwinkle snail. They were everywhere, especially along the rivers that went out into the ocean and back into the marsh. The salt marsh and the diatoms are in a relationship with one another. As rivers carry nutrients such as silica out into the bay, they can pass through a salt marsh. These grasses will take up the nutrients and hold them until they die and decompose and release them back into the bay. A portion of this is silica, and they tend to release the silica in spring when it was most needed by the diatoms. This allows for the diatoms to have a big spring bloom, and because the silica is present, they outcompete most of the other algae. With all this being said, what is ecology to you? When I think about ecology, I can't stop seeing the connections. Right along here, you can see a river flowing from this agricultural place into the salt marsh and out to the bay. This will carry nutrients with it from the lands as well from the city here. The city releases pollutants out into the water, into the seaweed that it creates. This road leads to the ocean, and the oceans often rise over the roads as the coastline is changing. The salt marsh can also lead out to the ocean from more inland places. And the diatoms and algae that they produce are in connection with one another. The diatoms and this seaweed both struggle for the same nutrients, but they are both present in the bay. Where is this? The light from the skies shines down all over the water to create the diatoms in the bay. And the coast is a long, long line with all different biomes along it. I like to thank everyone who made this program possible, as well as my mentors and the program coordinators. These are my citations. And I'm opening the floor for questions and answers. Go ahead.
Holy cats. That was amazing. Truly. I mean, I'm totally blown away because I've gotten little hints of what you were bringing to the table today, but you brought in history, you brought in culture, you brought in politics, you brought in law, you brought in the biology, you and then you all encompassed it all with the art, and it was beautiful, truly beautiful, and your words only just enhanced it. um Really loved the end, how I could see all the connectedness, and I loved how every time you changed your image, I could see the different connections. That was amazing. This needs to be a book, truly, because it's accurate, right? It's accurate science, it's accurate history, it's accurate politics, and I think people could digest this. And I'm really impressed. And I wish I had a question, but I'm probably going to have a million later. So stand by.
Hi, incredible presentation. I just want to second everything that Jill said. I'm a scientist and an artist myself, so this like really struck a chord with me. And I just wanted to hit on it. I don't have a question either. I just wanted to also have a comment. But I think it's really, really important to bridge that gap between hard science and the public. You know, the public's really interested in what the scientists are doing, but sometimes scientists are not the best communicators, and that's okay. But I think this is a great bridge to kind of bridge that gap between hard science and communication. I think it was really well done. It was beautiful.
Could you talk about the gradients in the diatom painting?
Yes. The lighter blue is supposed to represent like the sky, which would be like the zone where the sunlight can go through the ocean, and the green is when they're alive. And then the dark blue would be like the depths of the ocean when there's not enough light, so they can't live, but their dead shells would settle at the bottom and create some sediment along the floor.
So
Oh,
I asked the question, what does coastal ecology mean to you?
to me, well, I just gave a whole. This is what it means to me. These paintings. This is what it means to me. Also, my presentation is connected to Kyla's. It was in the same place, but also it was kind of about the same topic about like how different chemicals and processes all relate to each other and not separate in themselves.
I have a question. Where can I buy your art?
You can email me. It's my first name and my last name at gmail.com. And then you can tell me what paintings you want and what your budget is and if it's prints. I forgot them.
I don't want to interrupt anyone in the room. I'm so sorry. I can't see who has the mic in the space. Willow, I just want to share with you there are so many comments in the chat and also to Jaden and Kyla as well. Everybody is enjoying your all's presentations. This is fantastic. You're getting a lot of hype in the chat, everybody.
Oh, I'm loving that. First of all, I love your presentation. Wonderful, beautiful, Willow. Along with that, I'm loving that your presentation matches your clothes. Where did you get these clothes from?
These pants I sewed, I got the fabric from a school trip when I went to Ghana.
Wow.
This green shirt, I thrifted it and I dyed it green.
Period.
This vest, I hand embroidered the back.
I know that's right. I know that's right.
As well as the shoulders. Thank you.
Wow. Do you have a Depop?
What was it?
I want that fit. Like for real.
Thank you so much, Willow.